Hello and welcome to Beginners Python and Machine Learning. My name is Tim Cummings. Today we're doing an absolute beginner session for people who've never seen Python before, and so we're going to hopefully get you interested. We're a meetup group. The first week of every month we do an absolute beginner session, and then other Wednesdays we tackle more advanced programming topics. This here is a picture of our in-person session, and next week will be an in-person session. So if you're wanting to come in person, please register for that one. It's in the Brisbane Business Hub, which is in the Queen Street Mall in Brisbane. And it's always easier in person for us to help you get started. Today, I'll be taking questions on YouTube chat, so you can send questions in through YouTube chat, or also on Slack and the Learning to Code, which is in our Beginners Python Slack channel. If you want to join into that channel, I've got the instructions down here. You have to send an email to skypieproject@gmail.com. So obviously that's an email address, so you replace @ with the @ symbol and dot with the dot symbol. Now, today we're going to be using Google Colab for running Python, which means you don't even need to have Python installed on your computer. And I've given you a link. It's on this meetup page. It's also in the comments below the YouTube video that you're watching at the moment. You should see a link to this Colab research. So if you click on that link, it should open up in a new tab. And that's a copy of the notebook that we'll be using today. But you won't be able to save. It says changes will not be saved, but you can copy it to your own drive. So if you've got a Google account, you can copy this to your own drive and make changes, and that's a fantastic way of learning Python. So I'm going to show how it works. You click on copy to drive, and it opens up a new tab, and it will create a new one called copy of meetup 184 coding introduction. Now I'm going to click on connect, so save a bit of time later, and I'm going to click on share the notebook. So if anyone wants a copy of this one, which I'll be making a few changes to the original, then you can use this link, which I will paste onto the chat. So we'll just go paste there. And I'll also paste it into Slack. Alright, so now you've got two links for Google Colab. You can follow either of them, and you can make your own changes. Okay, so here we go. Challenge 1, install the software. We can do one of these: use a Google account or install Python on your computer. Now this is actually the hardest part about getting Python running, but hopefully with Google Colab we'll find it pretty easy, because you should already be on here. You should be connected. You see it says RAM and disk here, and I clicked connect before, so you should be able to do it and run Python programs. Now, for those of you interested in my children's Python coding course, I've got you see pythonator.com, and it's like Minecraft. It runs in a mind test world, and you have to do the Python exercises to actually play the game. Right, so if you're brand new to Python, you'll find you'll probably see different references to Python, and all different names. One's called CPython, Jython, IPython, Jupyter Notebooks. So I'll just tell you a couple of them. So Python is the language, and how it's implemented, they'll often put a letter in front of that to say how it's implemented. So CPython is the Python language implemented in the C language. and that's the one you'll most commonly be using. So that's what we'll be using today as part of Google Colab. But it'll also, Google Colab is a Python that's been augmented with some interactive features, and so it's called, I should have double clicked on that, it's called IPython for Interactive Python, and it runs in a notebook, so it's called Jupyter Notebooks, and they've even put a PY into Jupyter because of the Python. And what you're looking at here is a notebook. It's made up of cells. The cells can be either text or code, so that's an example of a text cell. This is an example of a code cell. So the code cells have got a play button here, so you can run the cell, what's in the cell. Comments in the code cells start with a hash sign, so you can see we've got 3 lines here, each one start with a hash, and the comments are all in green to help us know that it's a comment and not actual code. Now, one of the most important things when you're learning these languages is how to get help, and you can use the question mark to get help. So if I just type a question mark on an empty line here, and then I run that cell, and I run the cell by clicking this play button, or I can use the keyboard sequence Control Enter. If I run that, you see it brings up help over here on the right on how to use interactive Python. All right, so I'll just leave that. You can read that in your own at your leisure. I'll just close it up for now, and let's start writing some code. So what coding is, it's all about just writing simple commands to tell the computer to do something. So for example, if we wanted to display the number 5, we'd say a command of print, and in parentheses what we wanted to print, which is the number 5. So if I run this cell, the output for the cell comes below it, and here it is, it's displayed in that output the number 5. So that works in Python and IPython. Now in IPython, we don't even need the print to display the data. We can just put a number and it will display it. So if I run this cell, it'll display the number 4 because that was what was on the last line. Now when you put commands into a program, it runs them sequentially. It looks at the top and it just goes through line by line and just runs each command as it comes to it. So here I've put 2 commands, print 4, print 3. So if I run that, it prints the number 4 on one line and the number 3 on the next line. So, and then it's finished that little program that we've written. Now, unfortunately, in IPython, only the data on the last line is displayed. So if you want more, like we've got here, we've done 2 lines. We use print statements. If you try doing what we did with the number 4 up here with 2 numbers, 2 and 1, and we try running that, you'll see it'll only do the last line, which is what it displays the results of, which is the number 1. Okay, so we've got some tasks here. And I really suggest that the best way of learning Python is by doing the tasks. So our first task is to, in an empty cell, write a Python program to count down from 5 to 0 on separate lines. Now, you see what we've done some of this before in printing 4 and 3, so that should give you a hint on how you can do it. So I'm now going to solve this problem, this task. You can either have a go at it yourself and pause the video, or you can do it while I'm doing it and type it into this cell. I've even given you an extra cell that you can type stuff into yourself. And let me know in the chat if you got this to work or if I'm going too fast for you. So using what we learnt above, it's just we do print 5 is the first command. Then our next one is going to be print 4, then print 3, and this is really all a program is just a series of commands that just get executed sequentially from the top to the bottom, and print 0. So now if I run this program, we've now run a 6-line program that goes 5, 4, 3, 2, 1, 0, and that was the solution to this task. Now I'm going to provide another solution. These are already provided and they're included in the notebook, so you can see an alternative way of doing it. And this looks a bit different, so let's try running it and see what we get. So by running this, it starts off with a line saying solution 1 counting, and then it's got these texts that spelt out the numbers in letters 5, 4, 3, 2, 1, 0. So when you want to do text, print to display the text, you have to include that text in quotation marks so that Python knows that it's some text you want to display. And I'll show you later what will happen if we don't put the quotation marks in there. So this is talking more about the text that we've just used. Text data is called string, a string of characters, and we surround it with quotation marks. That can be single quotes or double quotes, and in Python that the type of this data is called str, which is an abbreviation of string. So we can find out what the type of any data is by using this Python function called type. So we enter that in, type, and in parentheses we put what we want to find out what type it is. So we've put a string of text, and it tells us what the type is. It's a type string. Now if we did the same thing for some numbers, and this time we don't put quotation marks around it, we see that Python calls it an int, which is short for integer or a whole number. There's a number without any fractional part. Python can also work with real numbers that have a decimal fraction. They're called floating point numbers. And let's see what Python calls them. Python calls it a float. Okay, now the different, when you're working with numbers, you can use these different operators, the plus sign, the minus sign, the asterisk, the slash, double slash, percent, or double asterisk. And they're each different operators. So you can write out arithmetic expressions such as 1 times 2 plus 3 times 4. So these operators are for addition, subtraction, multiplication, division, and then the double slash is integer division, and percent is modulo, which is getting the remainder of a division, and double asterisk is the raising something to a power. So let's have a look at 1 times 2 plus 3 times 4, and you see it came to 14. So if you were going to calculate that yourself, using the rules you learned in primary school, you do your multiplications first. So 1 times 2 is 2, and 3 times 4 is 12, and then you do your addition later. So 2 plus 12 equals 14. So you see Python respects those rules, and when it's calculating them. Okay, we've got a comment there. Lucio says interesting and a thumbs up. So thanks, Lucio. All right, now we can save the results from these expressions in memory locations. So just like on your calculator, you have some memories, you can store data. In a Python computer program, you can store data. And the way you save it is you give the memory location a name. So here's an example of giving the memory location the name of A and storing the number 5 in it. We say A equals 5. And then later on, whenever we print or do something with it, we don't have to do it on the 5. We can say print whatever is stored in memory location A. And these memory locations are called variables because you can change the data that's in them. So if we run that, store 5 into A, and then we print A, and unsurprisingly, it gives us the result 5. Now that's just storing a straight number in. We can do arithmetic expressions like 2 to the power 32, or even an expression in terms of other memory variables. So remember, A is 5, B is 2 to the power 32, so C will be 5 times 2 to the power 32. And let's print out what A, B, and C are. A is 5, so it remembered the memory location from the previous cell in this cell, and that's a really useful thing, and it makes it a lot easier to learn Python because you don't have to write your whole script at once. You can type some stuff and it remembers where you're up to, and then you can type some more stuff and it runs the new stuff that you've run. 2 to the 32, that's 4 billion, and 5 times that is 21 billion. So 4 billion, 2 to the power 32, that's really the maximum memory you can have in a 32-bit operating system is 4 billion bytes, or 4 gigabytes. And so that's why if you've got more than 4 gigabytes of RAM, you need to have an operating system with more than 32 bits, like 64 bits. Alright, programming would be very cumbersome if we had to type a line for every command we wanted to execute. So we can repeat commands by putting them into a loop. So there's different sorts of loops. There's while loops and there are for loops in Python. And the lines that get repeated are everything under the for that's indented. And this is a bit unusual between Python and other languages, is Python defines these code blocks by indenting code. So all the code that's indented is part of a code block, and the first line that's not in the code block is not indented anymore. So this loop here for z equals in 543210, that will go through this loop, and every time through the loop z will have a different value. The first time through it'll have the value 5, the second time through it'll have the value 4, then 3, then 2, then 1, then 0. So let's run it and see what it looks like. So it printed out the 543210, which before took us 6 lines, and now it took us 2 lines. Only those 2 lines there are the 2 that made that part work. And we've also summed up all these numbers by using a variable called total, and using this operator plus equals, which means take the previous value of total and add whatever the new value of z is to it and store the result in total. And so we get the total of the above numbers is total. Now these variable names, they can be quite long. The only thing is they have to start with a letter. You can't start them with a number. Okay, task 2, rewrite the loop to show a running total as it loops through all the numbers. Okay, we've got a question here. I jumped in slightly late. Will this Colab book be open after the course so I can read the beginning bits again? Yes. Yep, you can. This will be continually be shared, and so you'll be able to get both the original Colab notebook and the this new one that I've got now. And once you've saved it, once you've clicked on that copy to drive, it saves it in your own drive. So I can't change it after that. That's your own copy that you can do whatever you like with. Okay, back to task 2, rewrite the loop. So I'm just going to copy all the code of the loop and paste it into this blank cell here. And now, as it loops through the numbers, we want to print the total as well. Okay, so I'm just going to do a comma and total, and I'll just print all of these things with a space in between them. So let's run that. So you can see there's Z 543210, and his total started off at 5, then 9, then 12, 14, 15, 15. So you can see it's accumulating those values of Z as we go through. Alright, let's have a look at the solution that was provided. So this solution shows you how to do the same thing using a while loop rather than a for loop. And so the way a while loop works is you have a condition, and while that condition is true, it'll keep looping. So it's very important that there's something inside that loop that is going to make that condition eventually come to false, because if it doesn't ever come to false, you get what's called an infinite loop. And so what we've got here is z minus equals 1, which means reduce the value of z by 1. You could say equals, it's the same as saying z equals z minus 1. So calculate z minus 1, stores the result of that in z. So z is going to keep getting less, and eventually z will no longer be greater than or equal to 0. So let's run that and see what it looks like. It puts some text in here to make it a bit easier to understand what's happening. So it says the number is 5, the running total is 5. The number is 4, running total is 9. So it's the same result as ours, and it is just doing it a different way. Normally for loops are easier to understand. You don't have to be so concerned to make sure you don't have an infinite loop, but there are definitely some places where a while loop is better suited. Okay, write a loop which counts up from 1 to 5 and displays the factorial of each number as it goes. And the factorial of a number is factorial of n is 1 times 2 times 3 all the way up to n. Okay, so just before, like, we had a total, let's have a variable called factorial, and we're going to start it with the value 1. We can't start it with 0 because we're multiplying, and otherwise it'll always be 0. And we want to go from 1 to 5, so let's use a for loop. Z in 1, 2, 3, 4, 5, and then I put a colon at the end, and the colon really says the next line is going to be indented. And see, Google Colab even realized the next line is going to be indented because it indented it automatically for me. And I can just say factorial. Rather than plus equals, I can say times equals z. And let's print z and factorial. So we run that, and z goes 1, 2, 3, 4, 5, and the factorial goes 1, 2, 6, 24, 120. So that's one way of doing it. Let's have a look at the solution. The solution uses for z in range, and this is 1 to 20, just to show that this is a better way when you're using even larger numbers. And what range will do will go all the way up to, but not including its final number 20 there. So it'll start at 1, and because we give a beginning value, and it'll go up to the stop value 20, but it won't include 20. So let's run it and see what it looks like. So the first bit looks the same. Factorial is 1, 2, 6, 24, 120. So we could have stopped there, but it keeps going all the way up to 19, and you see it goes up to, but not including the 20, so it goes up to 19. So if we wanted to go just to 5, we would go range 1, 6. Alright, task 4, display the first 20 numbers in the Fibonacci sequence. So Fibonacci, if you've got the two previous numbers in the sequence, and we call them F1 and F2, then the next number in the sequence is just the sum of the previous two numbers. So if we start with 1, 1, then this number here is the sum of the previous two, which is 1 plus 1. Then this number is the sum of the previous two, which is 1 plus 2. Then 5 is the sum of 2 plus 3. 8 is the sum of 3 plus 5, and 13 is the sum of 5 plus 18. Alright, so how are we going to do that? Well, let's use variable names like were given to us in the task description. So let's say F1 equals 1 and F2 equals 1. Now we have to display 20 numbers, so let's do a loop that goes around 20 times. I in range 20. Now if I don't give a starting number, it'll just it'll assume the starting number is 0, and go up to, but not including 20, but that means throw 0 to 19, but that'll be 20 times for us. And it's really, we don't actually need to use the I, we just need to go around the loop 20 times to display 20 numbers. And our number we're going to display is the value that's in F1. So let's print F1. Okay, so now we've got F1 calculated. Let's calculate the next one. We'll call it Fn. Fn equals F1 plus F2. And now we can reset F1 and F2 so that they're ready for the next time we go through the loop. So let's say F1 equals F2, F2 equals Fn. And let's run that. Maybe I'll print I as well, just so that we can see where we're up to in the sequence. So this I goes from 0 to 19, and this is our Fibonacci sequence 1, 1, 2, 3, 5, 8, 13, 21, 34, and we can see that each one of those numbers is the sum of the previous two numbers. Now, when I did this, I needed to introduce a new variable Fn, because even though I'm going to store this result in F2, I couldn't do it before I'd stored the current value of F2 into F1. So I needed a temporary variable in the middle there. Now let's have a look at the solution and see if there was any other way of doing this. This would be the only way from what we've learnt so far, but the solution will teach us something new. Okay. So a feature about Python is that multiple assignment statements can be done on one line. So remember how I did F1 equals 1, F2 equals 1, and I put them on separate lines. I could also have done F1, F2 equals 1, 1. And so it just takes the first number, puts it in the first variable, takes the second number, puts it in the second variable. And what that means is that when after I've done the calculation in my loop, I can do F1 F2 equals F2, F1 plus 2, and F2, and I don't need a temporary variable to store the value of F2 while I'm assigning F1, because it calculates all the values on the right first, and then it assigns them into all the variable names on the left. Now I'm decided to only go through this loop 18 times, and let's run it just to see what the output looks like. So it comes up with the same last number, 6765. So I run it through it 18 times, but rather than put each line on a new line, I said in my print statement, don't end my print statement with a new line, which is the default, end it with a space. So it's ended it with a space, which means that these all get printed onto the same line until I get to the last one, and then when the last one I print both F1 and F2, and then it will print a new line to finish off, because that's the default. So the first 18 numbers get printed off inside the loop, and then the last two numbers get printed here, F1 and F2, and it means I haven't done any unnecessary calculations like I did here. I'm only displaying F1s, but I've calculated an F2 finally at the end. Alright, task 5. Now I hope you're having a go at these. They're not too hard, and we can certainly learn stuff by doing them. Count down in steps of 2.25 from 10.5 to -3 inclusive. Okay. So, how would I do this? I could try doing for I in range, and I want to start at 10.5, and I want to finish less than 2.25 because it's got to be inclusive. So let's go down to 2.20, and I want to go down in steps of sorry, I've got to go to -3, and I've got to go in steps of -2.25. Alright, so -3, but I've got to put a bigger number there, so let's go -4 because it goes up to but not including that number, and I'm going to go in steps of -2.25. Print I. Now the problem is if I try running this, I'm going to get an error. And the error is I can only put integers into the range function. So that's not going to work. So maybe I'll use the while function here. So I'm going to start with I'll say I equals 10.5. That'll be my starting value. While I is greater than or equal to -3, print I, and then we subtract 2.25 from that. Let's try that. And so that worked. So we started from 10.5, 2.25 at a time. We got down to -3 inclusive. Alright, so let's have a look at the solution. So the solution also specifies range can only work with integers, and it looked at the numbers that we're trying to use, and they are 21 on 2, which is 10.5, -3, and -9/4, which is the 2.25. So one thing we could have done was just work out the lowest common denominator of all of those, which is 4, and then we have a start numerator, a stop numerator, and a step numerator, so we just use numerators here, and then we print out our value of x divided by the lowest common denominator. So that's a bit complicated, but it just shows if you really do want to use range, then that's a good way of doing it. And I'll show you soon one of the reasons why this is actually quite a good way. But let's have a look at how we did this print statement. This one is called using an F string. So remember, a string is anything between double quotes or single quotes, and this one here is an F string, and because we put the letter F just outside it, which means that anything inside the string, inside curly brackets, we want to format. So we're going to evaluate and format it. So we can put an expression which we evaluate, which is x divided by the lowest common denominator, and then we put a way we're going to format it, and that comes after the colon in here, and the colon says we want it to be 7 characters wide, we want to show a decimal point, we want to only show 2 decimal places, and the number is going to be a floating point number. And by using this format, we're able to get all of the numbers to line up very nicely in our display. Now that's pretty complicated, but they're so useful, I thought it's worth showing you at this stage, and just try to get used to these format strings, and you'll be using them all the time. Okay, so let's get back to our problems with using a floating point step. We'll do a while loop here where we'll start with x equals 1, and we're just going to keep going down until we get to 0 and subtract 0.1 from it each time. So let's see what we get. So it starts off well, 1.0, 0.9, 0.8, 0.701. And that's the problem. And down here, when we get to close to 0, it's even 1.38 by 10 to the minus 16. And the problem is that 0.1 can't be expressed exactly in binary. So floating point numbers get stored as a binary number in Python. And there's a tiny little error, but if you keep adding or subtracting the same number on itself, these errors will just get bigger and bigger, and you can see that the errors builds up as we go on until this is the totally accumulated error after doing this 10 times. So that's why sometimes it's better to work with integers all the way through and then just divide by, because there's no error in the integers, and then divide by the lowest common denominator if you want to then find get the number at that point in the range. So this is the same problem using lowest common denominator, and you see that comes out perfectly right. So that's a problem with the float data type, which is one of the inbuilt types. It's very easy to use, and so it's really good for scientific applications where those small inaccuracies aren't important. But if you're doing something like an accounting application, then that's pretty important. So your options there are to either do everything in integers, like in cents rather than dollars, or there are other data types in Python. There's one called decimal, which will do everything that a floating point can do, but it does it without any of this binary error. The problem is it's just a little bit slower. So if you want speed, you use floats, and if you want exact decimal accuracy, then you use decimal. All right, now let's have a look at some other data types here. We're going to look at a list. And you define a list by using square brackets around your values. So you put all your values down, you put commas between them, and then you surround them with square brackets, and you can store them in a variable, and then you can even print that variable. So if I print my variable myList, it shows you square brackets and those 6 values. Now you can create a list using a loop. So I can start off with an empty list. This is an empty list here, just 2 square brackets. And every time I go through the list, I'm going to append a new value to that list, which is just going to be 2 times whatever this value of x is. So let's have a look at the list that this creates. And there we go, it's an even longer list, pretty similar to the one before. So task 6, create a list of numbers from 20 to 0, stepping down by 4 each time. Okay. So we can do a loop. So we start off with, I'll just create a list called L equals an empty list, and then I'll for x in range, and so remember range, start, stop, and step. So the start number is going to be 20. The stop number is going to be 0, but just past 0. So let's go down to -1. And the step's going to be -4. And then we'll put that value of x into the list. L.append x. Alright, you see that line is indented because it's in the loop. Now we're out of the loop because I'll take away the indent, and we'll print out what the value of L is. And run the cell. I just did Shift Enter then to run it. And there's our list, 20, 16, 12, 8, 4, 0. 20 to 0, stepping down by 4 each time. So that's good. Now the solution here is really made this a bit easier. Because it's quite a common thing to do, what Python does is it gives you this what's called a constructor, a list constructor. So it's just the word list, and in parentheses something that you can iterate over, or you can loop over, like in a for loop, and it will just take all the values from that and put them into the list. So that's made the code a little bit easier to write and quicker, and there's the answer exactly the same. Right, so task 7, create a list of the square numbers from 0 to 10. So can we do the same thing here? Not really, because range was going to return the values in a linear fashion, not in a square fashion. So we're going to have to use a for loop. So back again, L equals an empty list for x in range. So we're going from 0 to 10, so I'll just say 11. L dot append x squared. And then print the x. Print L. Let's print L. And there we go. There's our list, 0, 1, 4, 9, 16, all the way up to 100. So that's my solution. Let's have a look at the provided solution. So solution 7 is using a thing called list comprehension. Now it turns out that these 3 lines of code are a pretty common way of doing things. So Python's given us a way of doing the same lines, but same 3 lines, but all in one. So L equals the square brackets. So we start off with the square brackets here and here. What do we want to put in those square brackets? Well, it's the value of our loop variable squared. So I to the power 2, because I is the loop variable. And then we can put in what the loop is, which is for I in range 11. Now, they've used I as a loop variable, I used X as a loop variable. That's they both mean the same thing. So let's run it and see if it gives us the same answer, and certainly it does. All right, task 8, create a list of tuples for I from 0 to 10. Now a tuple is just like a list, but it's rather than using square brackets, it uses parentheses. So if I said, t equals 1, comma 2, print t. See, it just gives me 1, comma 2, this time in parentheses rather than in square brackets. And if I say, what's the type of t? It tells me that it's of type class tuple. And some people pronounce it tuple as well, that's fine. Okay, so the task is create a list of tuples. Okay, so we can create a list of tuples. So a list 1, comma 2. Well, let's start doing what they asked. 2, comma 4. 3, comma 9. So there is our list of tuples, but that's going to get tedious to write it all out for a long way. So let's write it out using, see if we can do it using list comprehension. So we say, there's our list name. We're going to open our list and we put in what we want, which is going to be I, comma I to the power 2 for I in range 11, and print that. And there it is, from 0 to 10. Yep, 0, 1, 2, all the way up to 10. And have a look at solution 8. This time we're exactly the same. So list comprehension is a little bit more complicated than absolute beginners, but I thought I'd throw it in just in case you're finding it too easy, and it makes you look knowledgeable if you show people that you understand list comprehension straight away. Okay, More programming structures. We've done loops. Now let's do conditionals. So conditionals use the if keyword, and they check if something's true. If it's true, it does one thing, and if it's false, then it will do whatever's in the else, or we can actually string them along with another else if. So in this case, we're going to check if it's divisible by 3, one more than a multiple of 3, or one less than a multiple of 3. And we're going to use the modulo operator to be able to calculate that. So let's run this code and see what it shows. So it says 0 divisible by 3, 1 is one more than a multiple of 3, 2 is one less, 3 is divisible. One more, one less, divisible, one more, one less, divisible. So this modulo operator is actually quite good if you've got some sort of repeating code that's got to go around in a cycle. Okay, task 9. Create a list of numbers from 20 to 0, stepping down by 4 each time, excluding numbers divisible by 3. Okay, so this is a little bit of complicated logic here. So we're going to create our list. We're going to step down from 20 to 0 for I in range 20, comma, minus 1, and we're going to go down in minus 1. So even if you're going down in minus ones, you still have to put the minus 1 because otherwise the default is plus 1, and if the start value is higher than the stop value, then it will just stop immediately if your step value is positive. But if it's negative, it'll keep going all the way down. Alright, stepping down 4. Oh, there we go, I wanted 4 anyway. Excluding numbers divisible by 3, okay. If I percent 3 does not equal 0, then append it. L dot append I print L. So you can see what I've done here. I've got a colon after my if statement, and so I've indented for that, but that's all inside this for statement, which was indented a bit. So I've got a single indent for the if, and then a double indent for the contents of the if. So 2016, 12 got omitted, 8 and 4 numbers, and 0 got omitted as well. Alright, so let's have a look at the solution. The solutions managed to use list comprehension as well, and that let's run it to see it, and they've put the if statement inside the list comprehension. So this structure here is also quite common, so they've come up with a list comprehension that can summarize all that into one line. Now I've got a question here. List defined by range is integer. Entering a real value redefines whole list as real. So it's not the whole list that's real. It's you can have some components of the list, some elements of the list can be real and some can be float. So let's I'll just create a couple of code cells here. So if I say L equals, and I create a list, so I could put in a few integers there, and so let's display that. So you can see they're all integers. Now if I can change one value of that equals, I mean I can even put in, so this, I'm setting the index here, so that's index 0, 1, 2. So let's put in a string, and L4 equals, and then I'll put in a real number because that's what you're interested in. And now let's have a look at what's in our list. So you can see here these two are integers. This is a string, this is another integer, and this is a real number. So you can have a mixture of integers and reals in the same list. If you're doing some coding and adding and subtracting, if you add a float to an integer, you will get a float. So if I say 2 plus 3.0, it's going to come up as 5.0. But if I did 2 plus 3, it'll come up as 5. So once there's a float in there, then the rest will be floats. Okay, we've got another question. So you've taught us how to solve these problems. What is the best way to actually internalize this knowledge going forward? Do you recommend drilling these as exercises, or do you have another approach? Well, definitely, I think doing these questions without looking at the answers is very important. And this is an absolute beginners session, so and we've got a few other absolute beginners sessions. So I think just working on those. Yeah, my route memory sucks, and mine does too. So I don't actually remember. I don't remember things, but I remember how to solve problems. So I'm trying to show you the things that are important to know, so that when you come across them in a different situation, you'll have an idea of why it's happened in a particular way. But we've got quite a few sessions. If you're finding that these are useful, and if you're finding you can do all of these, solve all of these problems, then yeah, try some of our other sessions, and then which are on the first Wednesday of a month, and they'll normally have the words. So it has the words absolute beginners in it. Then try to find something that's interesting you. We've got all our sessions are available online. I'll show you the so if we look at right at the beginning here, I gave you a link to GitHub. So if you go to that link, and these are all the sessions that are available online. Some of them are actually online as notebooks, and some of them are online as Python scripts. So the ones with my name in here, Tim, they're the ones that I've done, and so I do them as Python scripts. Arun likes to just save the straight notebook when he saves them, but they're not always there. But anyway, if you go into any one of these scripts, so let's find some of the, here's one, beginner dict and functions. It'll give you the link to the YouTube where you can watch the video. It'll give you a link to the Google Colab, and even to the GitHub. So this is the same GitHub. It's just a clone of this one. So they both point to the same data. Yeah, so you can go through all of those and try to find some that are interesting to you. So for example, the beginner ones are variables and data types. So they're the ones I'd start with, coding introduction. And then you get onto some more interesting ones. They're a bit more tricky, like JSON and regex. So if that's something that interests you, you can have a look at that. How to work with Mongo databases. How to Tkinter. So Tkinter is a way of doing graphical user interfaces in a operating system like Windows or Mac or Linux. So that's not going to be using Google Colab. That'll require you to have Python installed on your computer. Turtle graphics is a way of learning how to do particular sorts of graphics. LibreOffice is a Office suite that has a spreadsheet in it, and this shows you how to write Python programs that can control your spreadsheets. Okay, I'd like to learn to integrate things like LangChain and GPT plugins. Yes, so, and they're the ones that Arun will be doing. So see if you can find the videos in Arun's channel. He doesn't list them so here as much as I do, so it's a bit harder to find his ones. But if you subscribe to his, then you should be able to find his old videos. And he's been looking at LangChain and GPT for the last few weeks, so you can have a go at that. And if you come in next Wednesday, he'll certainly be looking at that as well. Okay, Xander's asked for subtitles. I think that's for the whole video. I'm not sure how, if there's an easy way I can turn that on. I thought it's doing a lot of subtitling automatically these days. But it would be pretty hard. I do provide a lot of what's important in the text of my notebooks. So hopefully you can read through that. All right. I think I had maybe one more to go. Storing range objects in variables. This is an example of how to... here we go. Usually there will be auto-generated ones, but it's not a live function. So if the video is available afterwards, it should be available. Yeah, so my videos are available afterwards. Yes, so hopefully they will get subtitles eventually. All right. Now I've showed you how to store some different things like strings and floating point numbers and integers and lists into variables. You can also store ranges in a variable. So that's a range is an object, and when I print it, that's what it looks like. And then I can use that range R in a list constructor and create a list from it. So that's 3, 7, 11. That creates it from that range. And task 10, rewrite the following code using nested loops. So we've got, there's a loop here. It runs through range 4, prints them all out all on one line, and then prints a new line. This does the same sort of thing, prints it all out, and then prints a new line. 3, 14 to 4. Let's run it and just see what they look like. So here we go. Range 4, 0, 1, 2, 3. Range 2 to 5, 2, 3, 4. Range 3, 14, 4, 3, 7, 11. And so this shows how the start, stop, and step work, and we're storing these ranges in variables and then printing them. Then using the variables to print the values of the range. But can we do that? Whenever you see repeated code like this, you start thinking, can I do this in a loop? All right. And so there's a solution provided here which does that. So I've got a tuple here. I could have done a list of all the values that are going into the range. I've done these as lists. And so the range arguments, each time it loops through that, the first time it'll take this, which will be square brackets, which will be a list with the number 4 in it. Then next I go through this loop, it'll have a list with the numbers 2 and 5. And then using that, I create a range. And I'm showing you an advanced thing here with the asterisk out the front of range arguments. What that says is explode the list and place each item in the ordered argument position. So range of the list 4 with an asterisk out just is range 4. Range of 3, 14, 4 with an asterisk out the front explodes that into 3 arguments. So it's as though I typed range 3, 14, 4. And then I can run the same code for each one of those, and we get the same results. It looks slightly different because range 4 has it can't tell whether you've put the range 0, 4 is the same as just range 4, so it doesn't know which one of those, how it got created, so it assumes it got created with a 0 out the front. Alright, so that was an advanced exercise at the end. See if you can understand that, what's going on, but if you can't, don't really worry about it. I just sort of threw that in to if people were finding it too easy. Okay, so I hope to see you next week. So the 14th of June is an in-person session, and the 19th of July is the next in-person session. Yeah, that's, if there are any questions in the meantime, you can always ask them in the Slack channel, although I noticed most people were using YouTube chat tonight, but if you put them in the Slack channel, I can answer them during the week, or someone else might be able to answer them during the week. Okay, Shelby asks, if I'm a complete beginner and I go to the next session on Wednesday, will it be over my head? Yes, there will definitely be stuff that's over your head, but some of it's over my head as well. So there's not a problem with going if you want to, and if you are interested in LangChain and GPT plugins, then it's definitely one that you should go to, and to see what's available. And there'll be other people there who can help you. And so it is a meetup, and we all try to help each other. So you can definitely ask questions, even if you go, I really don't understand, that was way over my head. But I find that the more I go to these machine learning sessions, even though some of it's over my head, I take in more every time that I learn it. And I'm quite good on Python. I just don't have the machine learning experience, but Arun's very good on machine learning, and so he's a great person to ask questions. And there's actually some other people there, like Mike Chambers. He turns up and he's very knowledgeable on machine learning as well. So there'll be people there who can help you. So still come along, especially if the topic is one that you're interested in.